Hi, let's continue our discussion in the reliability chapter. I believe that we have finished here and finished here, right? Now it's time for us to discuss the system reliability. That once you figure out the individual probability of failing or surviving after a certain point, then we need to combine all these probability to consider a system which usually is made of more than one component. Okay, so we're going to look at the series system, parallel system, and eventually mixed system. So system reliability, we usually have three different cases. Theoretically, this is a very high-level description of the reliability. If you think about it, we have a series system. In this case, once A fails, entire system will fail. Okay, the both unit has to function properly in order to have a functioning system. But that is not the case with a parallel system. This is a kind of safety device, right? This is a redundant system design. Even A fails, as long as B still function okay, this entire system can still function fine. Okay, of course it's same with A. If B fails, as long as A survive. So here we are interested in what is the chance of at least one functioning. Okay, here our question is, what is the chance that both are functioning, and things like that. And eventually we'll have a mixed system. As you can see, we're using both a duplication here. The overall is a duplication, but you got the idea. Here you need to figure out what is here and what is here. Another alternative design you can see is something like this, right? So you can have this kind of system. Overall, this is a parallel. Overall, this is going to be a series, but in one section of the system, it is redundant. Okay, whereas here, this overall using a parallel system, and particular section is also using a parallel system. But anyway, so we have learned how to calculate the reliability on each component, on each of those components. Now what I'm saying is we need to combine these individual component reliability to come out with a system reliability. So let's consider the series system first. So again, all of them has to be function at the same time, right? If you remember seeing this, this is one of your cheap Christmas lighting. So some of the chip units, as long as, sometimes one bulb is out, you see the entire line will gone. Entire line will be gone. Okay, that is what series system is all about. So theoretically, when you consider a system with n components, right? If the reliability of component I is Ri, okay, the reliability of the component is independent of each other. That means the failure rate of this light bulb is not dependent on this particular light bulb. Okay, what we're trying to emphasize is that each light bulb has its own chance of failing. It is not being interfered by the failure of some other light bulbs. Okay, so there are some cases where the failure of the previous unit has influence of the failure of the subsequent unit. So the easiest example I can give you is the one bullet in a revolver scenario. Okay, if you put only one bullet in a magazine of 6 revolver, and when you shot the first round, it didn't fire, right? Of course, when you fire the first shot, your chance of getting shot is 1/6. But what if the first shot didn't fire? When it triggered next time, the chance of getting fired is 1/5, 1/4, and so forth. In that case, the next round chance of fire is dependent upon the previous chance, where in this case, we're not considering that. Each component is independent of each other. Okay, that is a very important assumption here. If it's not independent, we cannot use this formula right here. Okay? And then eventually, based on the multiplication law of probability, what we do is reliability of the system is basically the multiplication of all individual component reliability one by one, like this. Okay, so let's take a look at the actual example here. So suppose that a personal computer system is composed of the processing unit, graphic board, and keyboard with the reliability of this, right? And respectively, that we're assuming that these are all connected to each other, and one component fails, the computer will not function correctly. So you can easily consider this as a series system. I mean, in highest level, we can see that as a series system. What is the reliability of system? This is fairly easy. You multiply the reliability one by one. Okay, multiply reliability one by one. So I think the result is 0.95 26335. Some of you may argue that, hey, if all three things are interconnected to each other, why the overall reliability is the lowest value, 975 here? Okay, it's sort of like a bottleneck, right? So if this guy brokens, an entire system will be not functioning properly, because this guy has the least probability of surviving after a certain point. And why we just take 97.5% as the overall reliability? It turns out that we're not calculating reliability like that. Okay, let me show next slide. So here is what can happen in the computer example. So component 1, component 2, component 3. So we need to think like this. So what is the requirement for the system reliability? All three has to function at the same time. So that is 95.3%. Okay, we have other cases where more than one will fail. Of course, in these cases, the system will not function properly. Okay, this is the behind logic. Okay, we want to see what is the chance that given component 1 is up and running, component 2 is also up and running, also component 3 is up and running. All three things, what is the probability that all three of them is going to be functioning at the same time without failing? So that is the reason why we are not simply taking the lowest value here. Instead, we are considering all these events. So this is, I think, the fundamental approach in calculating the probability, that we need to enumerate all the possible scenarios. Okay, and luckily this is a fairly simple example, that you only have two different scenarios for each component: fail or functioning. Okay, two states, fail or functioning. We totally have three components. Therefore, we have like 8 different scenarios we can consider, which you can see one by one in here. Okay, or some of you can also take advantage of a tree diagram. First guy, fail. First guy, function. Second guy, fail. Second guy, function. Fail, function, fail. Function, I forgot what these are, but you got the idea. So eventually you have 8 different scenario here that I'm just trying to emphasize that we are trying to identify the probability of one scenario that falls into the description of the problem, which is all three up and running. Okay? Yeah, this is a better way of drawing it. Okay? Maybe not. Here. Like this. Okay? There will be more coming, something like this, but in this case, this is a solution. Okay? Next one sort of involves the exponential failure rate. Okay, so suppose that 3 component series system has failure rate of this, and this per hour for each of its components. Please determine the overall system reliability within the first 100 hour. Okay, so if you recall what we have done in Thursday class, when you have the lambda provided, okay, lambda provided, you can actually calculate the probability that it will survive beyond 100 hours in this case. Okay, it's nothing but lambda, it's E negative lambda, t being the time here, which in our case is 100. So if you can utilize this, and you can obtain the probability that you need to calculate the system reliability. Okay, so luckily we have exponential failure rate already in here, and clearly it's telling us it's 100 hour, and for each of those components you can easily calculate what is the probability that it's going to out-survive 100 hour. Okay, so here is the solution failure rate, and here. So interesting thing here, if you watch closely, I am multiplying 3 together. Of course, that is related to this property, right? The reliability of system in series system is multiplication of all 3 components. If you are multiplying the reliability of all 3 components here one by one, that's what I did here. Okay, but if you look at here, exponential, I added these up, 0.005, 0.007, 0.004. I added them up and multiply 100. It suddenly become very simple. Okay, the reliability or the probability that will out-survive the first 100 hours is actually 20.2% in this case. Okay, so I hope my video is not blocking this area. So simply, I'm actually showing you the quicker way of calculating it. So if the exponential failure rate is provided, the reliability calculation suddenly becomes like this. Okay, you multiply all these survival function, one by one, and because of the product rule, okay, you may have learned this in high school, because of the product rule, when all of them are being multiplied using the same base, in our case, our base is E, exponential number, right? Exponential constant. So what we can do is we can add all of them. Multiply. And because some of you don't like this sigma symbol, that's the reason why I'm writing this. Okay, you multiply T. That's what it is. Okay, so this is a simple formula you'd like to memorize in order to calculate the reliability of a series system with exponential failure rate. Wow, that's quite mouthful. Reliability of a series system that uses component with exponential failure rate. Okay, so let me stop right here. I'm going to discuss the next topic in the next video.